Bienvenidos, Ushamdi, and welcome CTS230 Section 841 students for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3, or the Cisco Networking Academy Scaling Networks V6 course, and this morning's video tutorial and packet tracer solution set is going to be on packet tracer activity 10.1.2.5, where we're going to take a look at how to originate a default route into our OSPF v2 domain. Now, this activity is very, very straightforward. In fact, we're actually given the commands that are going to need to be run, but we want to talk about why we take advantage of OSPF when we're originating, right, or we're advertising this default route, and what the alternative would be. So again, it's very, very straightforward. We're going to set up a default route. So if we were to come to router 3 first, and let's take a look at router 3 here. Let's see what the OSPF routing table looks like right now. Show IP route, and we can see we're learning about the 172.16.1.0.2.0.3.0. So here's the 1.0. It's the LAN segment behind router 1. The 2.0 is the LAN segment behind router 2. The 3.0 is simply the transit segment, right? The serial connection here between routers 1 and 2. And let me ask you a question. Who would be the DR and the BDR between router 1 and router 2 on this point-to-point transit segment? Exactly. We're starting out with a trick question here. Remember, there is no DR-BDR election on point-to-point segments, because that is what OSPF is expecting, right? OSPF is expecting point-to-point segments so that then the SPF calculation can run, because the SPF calculation needs the point-to-point segments. And remember, our talk about the DR and the BDR is the entire purpose of the DR. In addition to making sure that we have fewer full adjacencies, right, and duplication of information, that we provide with the DR and the BDR a level of abstraction so that it appears as if we're dealing with point-to-point links to the pseudo node between each of the nodes on the multi-access segment. So again, point-to-point links, no DR-BDR here. So we see all of the OSPF routing information that we need, or that we're actually advertising right here. And again, we're on router 3, but take a look. Gateway of last resort is not set. So from router 3's perspective, you can see I've even got the transit segment here to the internet, but let's see what happens on router 3. If I were to say ping 64.100.1.2, are we going to have reachability? And we do not have reachability. And this is critical to understanding why and what the purpose of the default route is. So I'm trying to get to a network, the 64.100.1.2, for which I do not have a specific match in my routing table, right? Because here's my show IP route. Do you see an entry in here for 64.100.1.2? And the answer is no, we don't. In fact, if I was to trace to 64.100.1.2, how far would we get? Exactly, we wouldn't go anywhere, because again, our RIB, our routing information database, and let me do a Control-Shift-6 in there and kill that. Our routing information database has no information for that network. So we don't know where to go. Now, this is the value of the default route in OSPF, because there's a couple ways that we could handle this. And this, let me show you what the value is here. So, okay, I realize, you know what? I don't have a default gateway here set on router 3. So what I could do is come to router 3 and go into global config and say IP route 0.0.0.0, 0.0.0.0, whoops, 0.0, And I could put in the next hop IP, which would be the 192.168.10. Router 2 is 10.9, right? And let me make sure we get this right here. 10.9. So I could manually put a default route in. And that's going to get me as far as router 2. And then I could go to router 2 and put a default route in with the IP route quad zeros and point that out this serial interface or to the next hop IP, which is the internet. And then when I realize router 1 needs the same thing, I can come to router 1 and type in IP route quad zeros and then whichever way I want my default to go, either to router 2 or to router 3. And it would probably be router 2 because that's going to be the shorter way to go. So I could manually go router by router, and let me pull this out now because this is not the preferred way. This is not what we want to do. And for 3 routers, right, not that big of a deal. Maybe if we had 2 routers, even easier to put the default route in there on each of the 2 routers. But again, we're thinking about growing the network. What happens when we have 10 routers, 20 routers? Do you really want to have to go around to all of those routers and manually put in a default route statement with the IP route quad zeros? And the answer is no, you don't. And so what we want to do is we want to leverage, and this is the key word here, the dynamic routing protocol, right? And this is the dynamism, I think is a word actually. This is that dynamic aspect of OSPF. Or of any dynamic routing protocol, as we come to the router on which we want that default route to be originated. Whoops, let's bring this back here. To be originated, and this is the router that makes sense, right? And we talked about this in previous videos, that router 2 is the router that makes the most sense because it's the router with the default out to the internet, right? Or shortly it's going to have a default out to the internet. And so this is our OSPF domain right here. So if we make a big circle here, here is my internal network, which is my OSPF domain, right? So everybody inside the OSPF domain, if they don't have a longer, more specific match in their rib, they're going to have a default route telling them, hey, here's how you go to the internet. Because we have all the more specific information about the router 2 LAN, the router 1 LAN, the router 3 LAN, and that's great. But if they want to be able to go to the internet when they type in, ping 64.100.1.2, or in a more realistic scenario, when they type in www.ebay.com, .facebook.com, .amazon.com, the DNS is going to resolve that request to an external IP, one that they do not have an OSPF IGP route for. And so then it makes sense to simply send that traffic out the default, which will be this serial interface right here, out to the internet, and then let the service provider take things from there. And so let's go ahead and knock this out. On router 2, we go into privilege exec and then into global config. And this, again, very easy, straightforward activity. So we put our quad IP route statement in here and then the serial 010 interface. And again, we get that note telling us, hey, be careful, may impact performance, but this is a point-to-point link, so we're good there. And now what we're going to do is we're going to go into our router OSPF, and I'm going to assume it is 1. And let's say do show run just to make sure. Yeah, it is OSPF 1. So there's our OSPF configuration section. We've passive the gig interface as well as the serial 010 interface because, again, nobody out on the LAN is speaking OSPF. We're not going to be having any adjacencies out here, so no need to send those multicast packets to 224.0.0.5 or 0.0.6. And the same is true of the connection to the internet, right? We would not be running OSPF with the service provider. And this is a great example, right? And in the next course, Connecting Networks, we're going to talk about BGP. And this is a great example where you would simply use a static route. It makes the most sense. Running BGP here probably isn't the best decision. When we want to talk about BGP is when we have another connection to another service provider. Now BGP might be a better solution because we may want to have some routing policy. But in this scenario, this is where a static route is fine because everybody in your environment, there's only one way out of this environment. You only have one egress point to the internet, and there's only one ingress point from the internet. So it makes sense to make it that serial interface. So now we come in here and we're simply going to say default information originate. Now I'm doing a question mark here because I wanted to see if Packet Tracer also has the always option, because sometimes you want the default to be advertised even if the interface goes down, that serial 010 interface goes down. So I'm going to say default information originate. We're going to hit enter. And at that point, I can come here to router 3 and we can say do show IP route and take a look at what we've got. And here it is down at the bottom. So basically, the default information originate command, think of it as redistributing, right? It's kind of, again, abstracting, hiding the details of what OSPF is really doing behind the scenes when we say default information originate. It's really sort of a redistribute static, right? Because we've created that static default route and it limits it to the default network. And that's really what it's doing behind the scenes, right? Remember with EIGRP, we did much the same thing, except we literally said redistribute static. And so default information originate, you can think of it like a macro, right? Think of it as similar to a macro because it is redistributing the static default route, and it'll make sure that it only does the static default route into EIGRP. And here we can see that it is external OE2 information. And when we come up here to our legend, you can see OSPF external type 2, because again, it's from the static protocol is where we got this routing information, and that's where we redistributed it from, and we're redistributing it into OSPF. So now, right, the gateway of last resort is set, and you can see it's 192.168.10.9, which is router 2. So now, when I say do ping 10.100.21.2, right, we should have better success, or actually we are not going to have better success, and we're going to have to do it from the PC. And so the reason is it's this 192.168.10. That's going to be my source. If I come to the PC, cannot launch the PC software script. All right, let's try PC. Well, okay, well now it came back up. All right, so we'll come over here to the command prompt and we'll say ping, and what are we doing? 64.100.1.2, and let's see if we've got reachability out to the internet now. And so we do, right? And so this is going to work. We're not going to have any issues now. In fact, if I was to say trace to the 64.100.1.2, you can see that we trace all the way out and the trace is complete, and now we have connectivity. So again, we've got the 100 out of 100, and that's great, but let's talk about this option that I mentioned. So the always option, and there are scenarios where that is what you would want, and it looks like the screen is blanking out on me here. And give me a second. Looks like my virtual machine is not happy right now. So, and that's okay though. So let's talk about this option ever so briefly here. All right, looks like we're back. So if I was to come to router 2, and I was to go into interface serial 010. Now this is the interface to the internet. Let's say for whatever reason that interface goes down and I say shut, right? So now the interface on which that static default route is based, this connection is down. So if I were to come to router 1, and again, this is a router that we haven't been to yet, if I was to come there and say, show IP route OSPF, where is the default route? Right, it's not there. It's been withdrawn. And to prove, we saw it on 3, so let me come back to 3 here, and let's say do show IP route OSPF. You can see it's been withdrawn because the static default route is now pointing, right? It was pointing to an interface that was up. The interface is now down. And when the interface goes down, the static default is withdrawn from OSPF because, again, it's no longer reachable. So router 2 is smart enough to realize that this interface, which is the outgoing interface for that static default route, is down. And so it will withdraw that advertisement under the assumption that, well, if this interface goes down, chances are we've got another interface that we want to use. But in this scenario, there isn't. And so I want to show you an option that you can use with OSPF on the default originate. So router OSPF 1, and if I simply say default information originate, and I do a question mark, and you can see, boy, we've got a significant number of other things that we can do here, and we're interested in the always. And if you put the always, so default information originate always, means that even if the interface or that next hop IP that we're using in our static default route, even if that goes away, OSPF will not withdraw the default route. And you're probably sitting there saying, well, why would you allow router 2 to continue to advertise that default? And the answer is very simple, is you want to make sure that you continue to have all traffic that does not have a longer, more specific match in the routing table. You want to continue to have all of that traffic sent out that link, right? And in some instances, that makes sense because you want to make sure that only traffic that has a specific match is going to be floating around your environment here, whereas with the default information originate always, any traffic that doesn't know where it's going is going to be flooded out this interface, or basically black hole, right? Because the interface is down, it's going to black hole the traffic. But it ensures that the traffic continues to flow to that down interface instead of maybe possibly somewhere else in this environment, right? And so that's one possible use case where you always want to ensure that the default is being advertised even if the interface goes down. All right, well, this is going to wrap up, again, very easy, straightforward activity, but very, very important. And that is Packet Tracer Activity 10.1.2.5, where we took a look at OSPF v2 and how we would originate a default route. All right, thanks so much for watching, guys. Good luck studying for the final on Tuesday, and I will see you Tuesday night. Have a great weekend.